Okay, last but not least, photoelectric effect. Talia's favorite, I think. Or not, that was sarcastic. Question 10.1 is obviously a definition. Not obviously, but I think you've seen now that pretty much every question has a definition, which would make it, well, actually the one had 2 definitions, so I would say that's at least 10 definitions per exam paper, which is 20 marks, which you think is nothing and silly and whatever, but those 20 marks would be over 10%. So whatever mark you're getting for science at the moment, if you do your definitions for both papers, you'll get an extra 20%, which I think is probably beneficial. You'll get 10% extra for each paper. So strictly, that would probably be a 10% mark increase overall. But I'm just going to say 20, so hopefully you actually study your definitions, which I still doubt very much you're going to study your definitions. It's not difficult, though. It's just very boring. Anyway, so for the calculation, I really like these calculations. They're quite easy. Well, in my opinion anyway. They tell you, and I can do it nicely in different colors here. So wavelength of light. That is the wavelength of light, and the threshold frequency, and that is the metal, and they are asking you for the maximum speed. So you are going to give me the formula, the normal formula. See what they're doing here? I don't know whether you can see this behind all this other stuff, but anyway. So this is the threshold frequency going in there in the place of F0. Please just write this version of the formula, because this version of the formula, you can't get it wrong. So you see here, if you make a mistake here with which one you write, you're going to get something wrong. But just write the stock standard version and then choose the relevant one for this specific question. Maximum speed is that one, and the light wavelength is there. H and C are constants, and the mass of an electron is a constant, so everything else is a constant. And you get 5 marks for just doing that. Then they have something scary. This is an electroscope, and they're telling you a whole lot of words about it. Then they're saying ultraviolet light shines on the disc, and the foil collapses towards the stem, hangs vertically. How does the frequency of ultraviolet light compare to the threshold frequency of zinc? Write down higher than, lower than, or equal to. And that, I'm not sure it's going to be obvious, it's higher than. It's higher than because it collapses. So the electrons leave, which is why it's, so at the, when it's, sorry, so they give you pictures. It's negatively charged, it's like this. It stands apart. The reason why it collapses with the UV light is because the negative charges have left the foil. The negative charges have left the stem. So it is no longer negatively charged because the electrons have left. So the frequency of the ultraviolet light is higher than the threshold frequency of zinc because it's now neutral. So see, the electrons get ejected, and so therefore the negative charge is no longer there, and so therefore there's no more electrostatic force. So in this red one here, the electrostatic force is repelling because they're both negative, but it collapses when the negatives leave because the frequency of the UV light is greater than the threshold frequency of the metal. So that's 4 marks, and that's a bit spicy because no one has ever done that before. I haven't seen that in any of the other questions. Then they say green light is now shone on another negatively charged zinc electroscope, and the foil does not collapse. Will the foil collapse if the intensity is increased? It will not. Intensity will increase the current if current is happening. If the foil does not collapse because the energy is not enough. If you increase the intensity, you do not change the energy. So if I can just write it here, if you increase the intensity, you increase the current. If you increase the frequency, you increase the energy. And those two are not related. The intensity has got to do with the brightness, and the energy has got to do with the color. If you change the frequency, you change the energy. If you change the intensity, you're simply making more photons. More photons means more photoelectrons, but you only get more if you were getting them originally. In this case, the green light was not enough to make something happen, and so if you make brighter green light, it doesn't matter. It still doesn't have enough to make anything happen. So here you say no, because increasing the intensity increases the number of photoelectrons. It does not increase the energy. They have the same energy, the frequency is the same.